Hey everyone, so today for you I have Leetcode Question 41, which is find the first missing positive number in a list. So in this question, you're given an unsorted array and it contains only integers, and you're supposed to find the smallest positive integer that's missing. So in this example, you have a 1, you have a 2, but you don't have a 3, so you return 3. In this example, you have a 1, but you don't have a 2, so you return a 2. In this example, you have a 7, 8, 9, 11, 12, but you don't even have a 1, so you return 1. And in this question, the goal is to have big O of n time and use constant extra space. So I'll be going over two solutions, one how to achieve this, which I actually had to look up the answer to because I couldn't figure it out myself. And I'll also show you my answer, which doesn't use constant extra space. So, oops. So in this question, I have two examples here, and the second one kind of hits an edge case that we'll talk about. So you know your length of, in this question you have an array and the length of it is 6. So you know that the missing positive has to be in the range from 1 to 7, because if all of these were like 1, 2, 3, 4, 5, 6, and then a 7, that's the optimal case. If you didn't have a 1 through 6, then the answer would be something in that range. So we know it's going to be somewhere between 1 and length plus 1. That's where our answer will be. So we can take advantage of that, knowing that. And what we could do, this was kind of my solution, is we could create another temporary array. So another array of the same size. And what we could do is we could loop through our original array, and we could say, okay, if we have a number, and we could make this array, we could either make it the same size, or we could just make it length plus 1, and that will kind of make our lives a little bit easier. So we'll make a new array, we'll have it length plus 1, that's how big it is, and it's going to be a Boolean array. So what we're going to do is, the first spot, which is technically the 0th element, it'll have a true if it contains a 1 and a false if it doesn't. So technically in Java, when you create a Boolean array, everything's set to false by default, which is good. So what we'll do is we'll loop through this array, we'll say 4. Okay, in the 4th spot in our list, so put like, which is really our array sub 3, we'll put a true here. And then we look at the 6. We say, okay, is 6 in our range? And no, if you had like a negative number, we wouldn't even touch it. We'd say, okay, it's not in our range. I'll make this a little bit bigger. So we say, okay, 6. So in the 6th index, we'll put a true. So 1, 2, 3, 4, 5, 6. So we'll put a true here. 7, we'll put a true, because that is technically between 1 to length plus 1. So we'll put a true here. 2, we'll put a true here. 1, we'll put a true here. And then 3, so we'll put a true here. And then what you can do is you can just loop through all these numbers and find your first false, and that'll kind of represent which number was not included in the list. So that uses big O of n storage. I'm going to show you how to do it with constant storage. So for constant storage, what you're going to kind of do is you're kind of going to be sorting the list a little bit. So what you're going to do is you're going to find your first element, and it's going to be, okay, 4. So we're going to put this in our 4th spot. So make this a little smaller. So what we'll do is we'll put this in our 4th spot. So we'll put this in 1, 2, 3, 4, and we'll swap it with the 2. Sorry, I'm not the best swapper. It's a skill you gotta learn, swapping. And then we'll check, okay, does a 2 go here? We'll check, okay, first, does a 2 go here? We'll say no. Well, actually, before that, first we'll check, okay, is 2 in the range? And 2 is in the range, but it doesn't go here. So we'll swap the 2 also. So we'll swap this 2. Should make it easier to swap stuff, but such is life. And we're going to lose some of our commas, but it's okay. And then we'll say, okay, does the 6 go here? No. We'll put our 6 in our 6th spot. So 1, 2, 3, 4, 5, 6. So it should be swapped with the 3. And, oops, we lost the head of our 6. Okay, does a 3 go here? No. And is a 3 in our range? Yes. So we'll put the 3 where the 3 belongs. We'll move the 7 over here. And, okay. And we'll look at the 7. Now, the 7 is interesting because there is nowhere in here to really put the 7 because our length is only 6. So since there's nowhere to put the 7, we'll just move on because like there's no spot to put it in because the size of our list is only 6. So now we'll move to the 2. We'll check, okay, is 2 in our range? Yes, 2 is in our range. So we'll look to swap it. Does 2 go here? Well, 2 actually goes here, so we won't swap it. We'll do the same thing with the 3. The 3 is in our range, so we're good. It's between 1 and 6. And then we'll say, okay, does the 3 go here? Well, yeah, so we'll move on. So then we'll look at the 4. Then the same thing, so the 4 goes here. So we'll move on. Then we get to the 1. We'll say, okay, 1's in our range, but the 1 doesn't go here. So we'll swap the 1 with where the 1 goes. So we actually know the 1 goes here. And then we'll say, okay, here's the 7. Where do we put the 7? Well, the same problem as before. We know that it's not in our range, so there's nowhere we can put it. So then we look at the 6. We say, okay, where does the 6 go? So we'll swap the 6. The 6 actually goes here, so we'll keep the 6 here. So then, since our array is kind of, why is this pen not black? Well, okay, sorry. So then we can go through our array. We'll say, okay, the first element 1, okay, that's a 1. So we wanna keep. We know it has a 1. We know it has a 2. There's a 2 in the 2 spot. There's a 3 in the 3 spot. There's a 4 in the 4 spot. There's a 7 in the 5 spot, so it doesn't contain a 7. So we'll return 5 because that's what should be in that spot. So we'll return 5, and that's how you do it. So an important edge case is if you have 2 1s. So you look at the first one, you'll say, okay, the 1's in the 1 spot. That's what we're looking for. So we'll continue. We'll say, okay, 2. 2 is in our range. We can swap we'll say, okay, 1. 1's in our range. A 1 does not go here, so we'll swap them. So pick up the 1 and move this one and rip. So you swap. There you go, hot dog. And then you say, okay, where does this one in its spot? And you'll say no, so you keep swapping. So the last check you have to do is check if the number you're swapping with is the same as the other number you're swapping with. And if it is, you don't want to swap it. So I'll show you the code that goes along with this. So you'll create an integer I, and you'll set it equal to 0. And then you'll say while I is less than nums.length. So that means you're going to be looping through every number in I. So first thing you check is, that's what these two checks are. So say our length is 5. We want to check to make sure the number we're looking for is between 1 and 5, because those are the only numbers that we could really have that we hope we have in our array. So we check if the numbers are in that range, because those are the only ones we'll be able to swap. And then we also check like if the number there, if it's supposed to go where it is. So like if num sub I, say I is 0, is equal to 0 plus 1, so 1. So that would mean like um the 0th element has a 1 in it. Well, that's where it's supposed to go, so we don't want to do anything. In the last case, we don't want to do anything is well, these two check if things we do want to do, and these two check conditions we want to make sure we want to avoid. So we also avoid if num sub I, so say I is 1. So if num sub I is 1, or if I is 0 and num sub I would be 1, we want to check if this element is not equal to the element. This is the element we're swapping with. So basically we're checking if our first number is not equal to the number we're swapping with. So if they are equal, we don't want to swap, just kind of like the example I showed you here. We don't want to keep swapping those two because you'll kind of swap them infinitely. So you'll end up, if they're not equal, you'll swap whatever element was at that index with where it should go. So num sub I minus 1 is where it should go. So like if say you're looking at like the first element and it's a 6, so you'll swap I is 0, and which is the first element, so you swap the 0th element with this is the value, so this would be like a 6 minus 1. So you put it in the 5th index, which is where the 6 should actually go. So knowing that, we know that this is what we're swapping. So like say this is like a 1, or I is 0 and there's a 1 there. So well, actually then this check wouldn't be hit. So say like I is 1 and there's a 1 there. So and then so I is 1, num sub 1. So we'll say num sub 1 is a 1, 0. So minus 1 is 0, so num sub 0. So if num sub 1 is not equal to num sub 0, so that's just checking if there's two 1s there. So you'd swap, else you increment I and you look at the next index. And then what you can do is you look through all of your numbers. If it's not what it's supposed to be, you'll return what should be there. Else you'll return the length of the array plus 1. So like if you had the numbers 1 through 5 and that was it, you would return 6. So the length of it would be 5, and then you'd return 5 plus 1 is 6. So I hope this makes sense. I know I wasn't super clear about this part. It's kind of hard to show like a concrete example, but you can just know this is the index. These are the two indexes you're swapping with. So you can think of this as an index. So if the number at this index equals the number at this index, then you don't want to swap them. So I'll show you that this solution works. I already tried it out, and it gives you a really fast runtime. So really fast runtime. With my other solution, the first solution I showed you, oops. Oh, that's cool. It shows you a sample solution. Well, I was actually here in my other solution, so it wasn't that good. So yeah, I hope you enjoyed. Let me know if you have any questions or something wasn't clear, and I can try to help you. But thank you for watching.